Okay, so we continue on power flow diagram. Okay, firstly, let's start with series DC generator. Okay, so you have to know the power flow diagram. Okay, because of sometimes the equation is based on this diagram lah. Okay, so for generator, okay, let's start with P out. So for generator, P out is in term of VT multiplied by IL. Okay, VT IL, and then the power that going out from the line we call the losses. Okay, so we have losses in term of mechanical and electrical. So for mechanical, losses in term of mechanical, we have P mu. So this value is usually given in the data sheet. Okay, you can refer on the data sheet or for our cases in term of question lah, given in the question. And then PCA is copper amateur ataupun copper amateur lah, and then this one is copper field. So PCA is because of RA. Okay, remember the question for P, this one is P, P losses. P equals to I squared R. Okay, to determine PCA, which is the current that flow through RA is IA. So IA squared multiplied by RA. So dapatlah PCA. And then for PCF, the current that flow through RF adalah IA juga. So to determine PCF, IA squared multiplied by RF. So that one is the losses for electrical, and then this is the losses for mechanical. Okay, for series DC generator, okay, the P in, how we want to get the P in. Okay, because of you have to remember that, okay, this is represent generator, and then this is represent terminal line. Okay, so in our system, in power system, what we want to, okay, if you notice that, okay, the voltage line is always fixed. Okay, for example, 240 volt, 415 volt, 11 kV, 11 kilovolt. Okay, so that one is the example for line voltage. So what I mean here that, okay, actually on the generator side, okay, the utilities is try to maintain the power on the terminal side. Okay, so they need to make sure the voltage on the terminal line is fixed. Okay, as I mentioned earlier, okay, for example, 11 kV, okay, 33 kV, so VT is fixed. So for this case, what we can on the generator, it needs to fulfill, okay, the terminal line. Okay, so to determine P in, okay, you can starting from P out. Okay, P out, okay, plus all the losses, we can get P in. Okay, P out plus all the losses, electrical losses and mechanical losses, we can get the P in. Or from this side, okay, PM plus P mu, we can get P in. Okay, from this side, P out plus PCF plus PCA plus P mu, we can get P in. Okay, so that one is for series DC generator. Okay, actually for generator, okay, sama je konsep dia. Daripada P out, okay, we start with P out plus PCF plus PCA plus P mu, kita akan dapat P in. Okay, okay, same goes for shunt. Okay, starting from P out, PCF 1, PCA plus P mu akan dapat P in. Okay, and then for compound, okay, it has additional losses which is because of PCF2. Okay, so to determine P in, we can start with P out, which is VT multiplied by IL, okay, plus with PCF1, PCF2, PCA and P mu. Okay, so here the PCF1, okay, you can refer because of RF1, and then the current flow through RF1 is IF. So to determine PCF1, IF squared multiplied by RF1. So you can get the PCF1. And then for PCF2 and PCE, okay, the current flow is IE. Okay, the current that flow through RE and RF2 is IE. So determine power across ataupun drop on RE and RF2 is IA squared multiplied by RA to determine PCA, and then IA squared multiplied by RF2 to determine PCF2. Okay, so how we want to determine IF? Okay, because of this is parallel. Okay, when parallel, the voltage is similar, so we can determine IF by VT divided by RF1. So you can get IF lah, the value of IF. Okay, so we move on. DC series DC motor. Okay, series DC motor. Remember that the direction of current is from terminal line to the motor lah. Okay, so for this case, okay, for motor, okay, we can determine P in first. Okay, because of this is fixed. VTIL is fixed on terminal line. So we can determine P in equals to VT multiplied by IL. Okay, itu adalah P in. And then PCF, okay, you can refer which current is flow on the particular resistor. Okay, for example, for this example, the I line is equals to IE. So you can determine PCF by I squared, IL ataupun IA multiplied by RF. Same goes for this one. Okay, IA squared multiplied by RE. And then this is electrical. Okay, remember this is electrical part, and then dia akan pergi ke mechanical PM. Okay, dia beza dengan generator. Okay, generator on the amateur side. Okay, PM is always closest at amateur side lah. Okay, so PM is closest on P out, which is on our amateur side. Okay, and then PM, and then P mu for mechanical losses, and then lastly adalah P out. So for this case, we can determine P in first. P in equals to VTIL, and then to determine P out, okay, P in minus PCF, mana PCA, mana P mu akan dapat P out. Okay, beza dengan sebelum ni, P out plus dapat P in. So this one P in minus dapat P out. Okay, sama juga untuk shunt. Okay, this is because of RF1, IF squared multiplied by RF1, IA squared multiplied by RA, and then this is given on the equation. So P in VTIL minus this one minus this one, we can get the P out. Okay, so remember to determine IF, okay, because of this is parallel, you can divide by VT. Okay, VT divide RF1, you can determine IF. Okay, and then lastly for compound DC motor, okay, there are additional losses which is because of RF2. So remember the current that flow through RF2 is IE. So to determine PCF2, IA squared multiplied by RF2, and then VT equals to P in equals to VTIL. So to determine P out, P in minus losses, and then you can get the P out lah. Okay, so this one is for power flow diagram. Okay, so this is power in DC generator. So ini samalah, it's like what I have explained just now, to determine P in, P out plus total P losses, and then P out is equals to VTIL because of, okay, need to be maintained. VTIL is need to be maintained on the terminal side. So that's why lah we can determine P out. Okay, and then this is total of P losses. Okay, PCA is amateur copper losses, field copper losses, and then P mu, okay, mechanical losses. Okay, either stray, friction, wind edge, and extract lah. Okay, and then for DC motor, power in DC motor, okay, P out equals to P in minus P total P losses. Okay, for motor, the P in is equals to VTIL. Okay, so this is from terminal line. Okay, So remember for motor ni you can assume as you punya load. So load ni dia akan dapat daripada supply. So supply adalah in term of VTIL. So yang ni adalah from TNB. P in equals to VTIL, and then dia akan supply to the motor, which is kita punya load lah. Okay, and then beza untuk generator. Okay, ini adalah kita punya demand. Okay, on the generator side dia akan fulfill demand. Ini adalah kita punya load. Okay, P out equals to VTIL. Ini adalah kita punya load. So yang ni kita punya supply for DC motor. For the generator, ini adalah kita punya load lah, kita punya load. So kita nak generate power that we supply to the load. So that's why lah dekat load side, okay, the voltage must be fixed. Okay, if I can draw the circuit. So for example, this is on the generator side. Okay, generator side dia akan generate voltage and current. So this is our VT. Okay, our terminal voltage. Okay, so this is IL lah, and then this is load. Okay, for example, for this case we represent as a motor. Okay, so the generator need to generate the voltage and current, okay, that used by the motor. So the rating for the motor is fixed on VTIL. So generator must consider the rating for the motor. So that's why lah the VT and IL is fixed. Okay, so we not change the this one. Okay, so generator need to consider the demand side ataupun the load side. Okay, so this one is P out for generator. Okay, P out for generator, but P in for motor. So P out, okay, fixed on VTIL, and then P in for motor pun fixed on VTIL. So ni adalah P out untuk generator, but P in for motor. So I hope you can understand why for generator P out is fixed, but for motor P in is fixed. Okay, because of this one lah. Okay, generator generate voltage and current, but for motor dia akan use the power and current that generate by generator. So that's why lah on the side is fixed VTIL. Okay, so for power in DC motor, okay, another equation that we can consider here adalah PM equals to P mu plus P out, ataupun PM equals to EE IA. So EE adalah armature voltage, ataupun for motor okay, you can consider sebagai EC lah, counter EMF. Okay, multiply by IE, we can determine PM. Okay, so lastly the second last part which is efficiency. Okay, the general equation for efficiency is P out over P in multiplied by 100%. Okay, for generator, okay, we know that P out is VTIL. Okay, remember generator generate voltage and power, so VTIL lah, and then P in based on VTIL, P out plus total losses, and then we can determine P in. And then for DC motor, okay, remember our P in, okay, our P in is in term of VTIL, because of, okay, we use power generate by generator. So in the terminal line lah, P in is VTIL, and then P out is VTIL minus total losses divided by VTIL multiplied by 100%, and then we can determine efficiency for the motor. Okay, so beza this one is minus, and then this is on the nominator, and then for this one is plus, and then P in is on the this one is on the nominator. Okay, so torque, okay, the equation for torque, okay, P equals to omega T. So omega adalah dalam unit radian per second, which is speed in radian per second, and then omega is equals to 2 pi n over 60. Okay, if we can substitute omega with 2 pi n over 60, so the equation will be 2 pi n over 60 multiplied by T. So what we want to determine here adalah T. So T equals to 60p divided by 2 pi n. So n adalah speed in RPM. So this is the equation used to determine torque. Okay, so actually torque, we can either determine mechanical torque, output torque. So it depends on P. So if the question asks for mechanical torque, so P is PM. If the question asks for output torque, so P adalah output power lah. Okay, and then the unit for torque adalah Newton meter. Okay, and is speed in revolution per minute ataupun RPM. Okay, so this is okay, the equation for torque. Okay, either T out. Okay, we use P out. For mechanical torque ataupun TM, okay, we use PM lah. And then for loss torque, okay, we use P mu. Okay, loss. Okay, ini we consider torque mechanical power, losses for mechanical power. Right, so if we continue on example 1 for the next video. Thank you.